Good morning, thank you very much. I teach at Universidade de Fernando Pessoa. It's an architecture and urbanism university located in Porto, okay? And what I bring here is how we integrated BIM technology to teach sustainable construction inside the curriculum, okay? BIM technology as a design tool is becoming the standard of the business, okay? But even if it is, for most of us, very clear that this is going to happen, sooner or later, the architecture schools, especially in Porto, are very old-fashioned, if you want to call it. They stick to old methods. They still teach AutoCAD thoroughly throughout the whole curriculum, and they don't really understand still what BIM technology means. Why? Because architects still don't use them, okay? And as universities want to prepare students to the market, the architectural market, to work at the offices, if those offices don't use BIM technology, usually universities don't feel the need to do that. I heard a while ago that architects were much more artists than BIM technicians. Well, we don't want them to be BIM technicians, but we want them to understand BIM, what it means and what it can do, okay? And this is a big task, especially, again, in the city of Porto. Students, each one of these students in this class thinks that they're going to be the next Pritzker Prize, okay? Because we have two of them over there, and they work at the same building, okay? And there is a Pritzker aura around architecture schools. And so when sustainability comes into hand, it's very hard to get to the students. Why? Because sustainable construction, ecological principles, bioclimatic, this is all things that are going to somewhat change their big ideas, and their big ideas are pretty much sacred. So, but I think that we have to prepare these future professionals, and we have to show them the BIM advantages so that they can press the workplace, the market, into working with information, which is something that most of the architects now still don't understand what it is. Access, produce and insert data, which drives to data-driven decisions in design projects, which is something that is still pretty new to them. Okay, the integration of the whole building in a single platform, okay, using some protocols, of course, and we are still working on that as well, and linking knowledge and professionals. And this is something that the BIM platforms do with much ease. Okay, so on the sustainable construction class, okay, most of the schools that that already work with this are still focusing on energy efficiency. And just energy efficiency, okay? And this is something that we have been figuring out, and we've seen that most of the schools are still on this plateau, but we want to push buildings to their life cycle, because energy efficiency is just a part of sustainable construction. So we are really looking forward to a more holistic approach, and this is basically BIM is going to help us solve this in a pretty easy way, because this involves a lot of calculus, and this involves a lot of information that students are probably not ready to still work with, okay? So we want to work with passive and active principles, okay, and they're different for energy efficiency, of course, but we also want to measure the impact of the materials and the construction systems adopted for the building on the environment. Up till now, sustainable construction was taught using basically a theoretical base, okay, which we still maintain, of course. All these theoretical principles have to be present so that students can know and read and interpret all the results. But it was very hard for them before, because they had to make calculus by hand, they had to make geometric drawings to know, for instance, the angle of the sun, etc., and the way that the windows were facing, etc. So it was hard. And what we noticed was that students simply didn't use it. Okay, they just wanted to pass sustainable construction, and that was it, and then forget all about it. Okay, because it was difficult, it was hard. Okay, so we still give students all the integration with the natural environment and all these principles, and we try to make them think what, why, and how am I going to integrate this, and how easy is it going to be. And so for this, we start using case studies. Okay, but they're case studies with a little twist. So we try to come from the most traditional architecture that we have there, okay, in Portugal. Then we go to all our architectural heroes like Sotomoro, okay, so we show them how does this behave, okay, and we go all through some of the more conceptual buildings that the students usually are so fascinated about. But all of this comes with a report, okay, and this report is showing us how much those buildings weigh on the environment, okay, from the most traditional ones to the most sophisticated ones, okay? And so at this point, students get a whole new approach, a whole new perspective towards what architecture is and what buildings are, okay? And so we ask students to make a practical exercise. Once they have these case studies and once they have the theoretical knowledge, how can they improve the sustainability impact of a future or existing building of their choice? So they just have to respond to three things, okay? So to make things more simple for them, they have to be residential buildings, they have to be freestanding, so that they have windows pointing to all the quadrants that we have available, okay? And they have to be single family, so that students don't get over enthusiastic and come up with very big models, and they're very hard to do, and they don't have the time to finish the assignment. And so from this point, students are going to model their buildings in a BIM environment. Okay, we are using now ArchiCAD, okay, and we are using EcoDesigner Star to make all the calculations. But if students are proficient in Revit, they can use Revit or any other BIM platform. It's not very important. And so we come up from buildings that, even though they're residential, they're very complex, existing ones. Some students basically create their own models, either working on project or not. And some of them get enthusiastic about the trying out what their heroes are doing. And so they model, for instance, this house is again from Sotomoro. There is a fascination for them there in the schools of Porto, for him and for Cisa. And for Sotomoro it's very easy because the architect usually publishes all the details, so it's easy for them to know all the detailing of his buildings. And so at this point, students have to work with numbers and work with information. And so all the layers from the walls, from the roofs, from the slabs, they have to be inserted correctly. Okay, and they start to sense mass and matter and how much those weigh on the building. Then they work for the first time with weather information, which is something that usually they don't know. So they have to insert the project location, and they have to study, for instance, solar radiation, the amount of energy that they have available. Okay, the air temperature, what are they going to find throughout the year? The relative humidity and the relation that it establishes to the feeling of heat and cool, and the wind speed, okay, for natural ventilation, for instance, and of course, where does the wind come from throughout the year, because this is also very, very, very important. And so, at this point, they are already questioning some of the design decisions that they have already made. After this, we go to the energy sources and the active systems. So basically, they fill out these forms where they start using the CO2 emissions for each of their energy sources, and they start filling out what systems are ventilation, air conditioning, if they are using or not, and at what time and what temperatures do they want in each zone of the building. So from this point on, they basically just detail the building, and for the first time again they are acquainted with thermal bridges, which is something that a lot of people talk about, but students usually don't really know what it is until they see these graphicals about their own buildings, and they can really relate to them. Okay, so this is the procedure that helps students to detail their buildings to the last effort, and they start getting information out. Okay, so the embodied carbon, using simple lists from ArchiCAD, can give you right away in real time, with no effort at all, the amount of CO2 of embodied carbon of every material that they used on the building. Of course, this is a very simplified list. The lists are much bigger, but students for the first time relate carbon to matter, okay, which is something that usually they don't even know that it exists, okay, and they start working with numbers. Since CO2 is a good unit, we keep on doing that throughout all the energy that the building needs. And so CO2 becomes the key, along with BIM, for students to interpret and to understand what is going on with their buildings in environmental impact. Okay, so the improvements that we saw on those buildings, I have here some examples of embodied carbon and embodied emissions, are huge. So students sometimes they get over enthusiastic with this. And the main point is something that was abstract, that was lengthy and embodied a lot of calculus and was not straightforward, simply becomes something that they can relate to and they can work very easily with. And so with these graphs we can see that the levels of improvement are huge in each of the buildings. Some of them get a little bit over-optimized as well, because students try to make a huge effort for this. Okay, and they also go back, always are going back to the passive the passive systems instead of investing on the active systems because of the CO2 reduction, the natural CO2 reduction. So basically we carried out, of course, these are the percentages of improvements that students made. These are some surveys that we give students at the beginning of the semester and at the end of the semester, and we can see that their knowledge increases exponentially and greatly. And so basically what we can conclude is that sustainability for students basically becomes the balance between matter, okay, and energy. And all this complexity is basically simplified using BIM systems, okay, and understood and measured using CO2, and this method really worked. Thank you so much.